Hello class. Today's learning goal is I can dilate an image when given a scale factor and determine the rule of dilation. And I can determine the difference between and identify similar and congruent images. So let's go ahead and get started. Dilation. What is it? It's a transformation that produces an image that is the same shape as the pre-image, but different size. Okay. So everything we've done so far, all the transformations we've done so far, have the same size and same shape, but this one has a different side. The angles remain the same, so the images are similar but not congruent. Scale factor. We've talked about this when we were talking about proportions. And a scale factor is the ratio of a side on the image to its corresponding side on the pre-image. Okay. And so this is what we multiply the original lengths by to get the new lengths. And we'll also learn a little bit more about this, how we can apply it when we have coordinates as opposed to side lengths. A ratio is a comparison of values, as you already know from last year. Okay, so here we are asked to dilate this with a scale factor of 2. Okay? And what we do with this is we take the original coordinates, so this one for m is 0, 2, and we multiply both the x and the y coordinates by 2. So 0 times 2 is still 0, so we're going to still be right here. And then the y coordinate of 2 gets multiplied to 2 by 2 to get to 4. So right here, 0, 2 becomes 0, 4. Here, L, which is 2, 2, becomes 4, 4, because we're multiplying both of them by 2. K, which is 2, negative 2, becomes 4, negative 4. And N, negative 1, negative 2, becomes negative 2, negative 4. Okay. And so once we plot all of these, it kind of looks like this right here. Okay. And so this is considered an image that is scaled up by a scale factor of 2. Okay. Notice that this length used to be 2, now it's the length of 4. And this length right here used to be 4, is now a length of 8. Same thing for all of these right here. Okay. Are the shapes congruent or similar? Well, you can see that the side lengths are different, but the angles are all the same, so therefore they are similar. The shapes are similar because the angles are the same, but the side lengths are different. And what is the location of an apostrophe? That is negative 2, negative 4. Okay. Here we are to dilate something by the scale factor of 4.5. So we take each one of these coordinates and multiply them by 4.5 and graph that. Okay. You will get some decimals for answers. You can plot them accordingly. Okay. Go ahead and try this one out on your own. If you do this, you find that these are the new coordinates, 0, 4.5, negative 4.50, and 4.5, negative 4.5, which gets us something that looks like this right here. Okay. Are they similar or congruent? Again, this is dilation. It means the lengths change, but the angles do not. Therefore, it is a similar figure. Okay, not congruent, but similar. And what's the location of Q apostrophe? That would be negative 4.50. So notice that both of these examples have a scale factor that is greater than 1. Okay, that means that the image is going to be bigger than the pre-image. Here, okay, we are asked to dilate something by a scale factor of 0.5. We still apply the same rules, but we're multiplying the x and y coordinates by 0.5. But that's going to create a smaller image. Okay, so go ahead and try this one out on your own. Here we have these are our original coordinates, and these are our new coordinates. Okay, multiplying each one by 0.5, which is the same thing as dividing by 2. And so we're going to cut each one of these in half, which results in an image that looks like this. Again, these are going to be similar images, even though this one is a dilation scale down. They are still going to have the same angles but different side lengths. Y apostrophe is 1, negative 0.5. Let's say that we are given a figure and its image, okay, so a pre-image and its image, and we're asked to find the rule. Okay. To do that, we have to do several things. We need to pick a point in its new location to compare. Okay, and then find the scale factor by dividing the new x-coordinate by the old x-coordinate, and or the new y-coordinate by the old y-coordinate. We'll talk about why you may have to do this with one or the other. Okay, and then we write the rule. Okay, so this gets you the scale factor, and we say dilate by a scale factor of a certain amount. So for here, we have this figure. Okay. I'm going to use z. Z starts out as 2, -2 and becomes 3, -3. Okay. So again, we're going to use this. Okay. And what we're going to do is we're going to do 3 divided by 2 and -3 divided by -2. If they both get you the same scale factor, then that's going to be the scale factor. Okay. Oftentimes we only have to do this once, and we'll talk about why. But both of them confirms that the scale factor is 1.5, so therefore we're going to write the rule dilate by a scale factor of 1.5. Okay, 1.5 means that it's going to be bigger. The image is going to be bigger than the pre-image because the scale factor is greater than 1. Notice that if we chose W, okay, 0, -2, and W apostrophe is 0, -3, we can't use the x-coordinate. Okay, we can only use the y-coordinate in that case. Okay, so it might be helpful to use something that's not on an axis. Okay, because if you do it on, you choose a point that's on an axis, we can only use one of the coordinate points, not both, because we can't divide by 0. So this is the pre-image right here, and this is the image for this one, and it has to find the rule for the transformation. Go ahead and try this one out on your own. We're going to pick a point. I believe I use k, right? So it is -1, 2, and then becomes -2.5, 5. And if I do 5 divided by 2, we get 2.5, and I get -2.5 divided by -1, we get 2.5 as well. Notice that scale factors are always going to be positive. Okay, and the reason for that is because we don't really when we divide, we don't really change the coordinates that they're in. Okay, when we do dilations, the coordinates stay in the same quadrant that they usually are in. As a result, you're going to either be dividing a negative number by a negative number or a positive number by a positive number when we find the scale factor. So scale factors are always positive. The rare certain cases of that is when there is a reflection, but we won't be addressing that this year. Thus, we can write the rule that the dilation is of a scale factor of 2.5. Go ahead and try to practice out on your own.